So class, question 12, we are given figure 1.9. We have two parallel plates set at a distance of 15 millimeter apart in a vacuum. So the top plate is connect to positive 200 volt and the bottom plate is connect to a potential of negative 200 volts. So there is a potential difference between the top plates and the bottom plates. So if the electron is released perpendicular to the field, A, sketch the path of the electron beam in the electric field and also after emerging from the electric field. Then B, we need to explain the shape of the path we sketch, and C, determine the magnitude of acceleration of the electron for the component X and Y. So class, so we understood that there is a potential difference between the top plates and also the bottom plates. So in between the space of the two parallel plates, we are going to create uniform electric field. So we are going to create uniform electric field in between the two parallel plates. Then we have an electron which is released perpendicular to the field. So perpendicular, see? Yeah, is perpendicular, whereby our electric field line is running from terminal positive straight downwards towards the terminal negative, but our electron is being shot from the left to the right. So we want to sketch the path of the electron beam in the electric field and also after emerge from electric field. So class, what kind of path the electron will perform the motion? It much more depends on the electric force acting on the electron. So electron is a negative charge. So upon entering the electric field, bila electron ni masuk dalam electric field, it will experience electric force. So this electron experience electric force. So electric force acting on the electron kemana? So electron is a charge negative. So for sure, electron will experience attraction force towards the plate positive 200 volt. Okay, so the top plate is positively charged because it is at high potential 200 volt. The bottom plate is negatively charged. We understood is negatively charged because it's set to a potential of negative 200 volt. So electron is negatively charged. So this electron will experience a attraction electric force upward. So dia akan ada electric force acting upward. Okay, so the electron have a very small mass, so the mass of the electron is negligible, the weight of the electron is negligible. So apa yang kita akan nampak ialah, so the electric force will try to drag the electron upwards. So what happened to the motion of the electron? So the electron will deflect upward. Okay, so as it moves across the field, the electron will do projectile motion. It will deflect upward and then emerge from the parallel plate. So this is the sketching of the electron beam's motion in the electric field and after it emerged from the electric field. So we are going to do projectile motion. So dia akan lakukan projectile motion. So this is the sketching. So this will be our answer for question A. So this is the sketching of the motion. Then B, explain the shape of the path. So the electron is perform projectile motion. So kita kena explain how come we get this kind of path of motion. So kita boleh break it out into two. In between the plates, masa dia berada dalam plates tu, as the electron move in between the plates, we find out that the motion path is parabolic. Okay, the motion path is parabolic, means that it's doing projectile motion. Why? Because the electron experience electric force. upwards. Okay, due to this electric force acting upward, so the electron will be dragged upward lah. So dia akan buat parabolic motion path ke atas. Okay, and then after emerge, what happened? After emerging from electric field, okay, bila dia keluar daripada electric field, there will be no more electric force acting. So there is no electric force acting. Tidak ada lagi electric force yang akan bertindak ke atas charge tu, sebab dia dah keluar daripada parallel plate, kawasan elektrik tersebut. So there will be no electric force acting. Thus, the electron will move in straight line. It will continue to move in straight line. Okay, so we have explained about the motion path that we draw for question A. Then question C, we need to determine the magnitude of the acceleration of the electron for component X and also component Y. So class, if you refer to this diagram, we are doing projectile motion. So we want to determine the acceleration of the electron for component X and component Y. So for this electron, upon entering the electric field, it experienced an electric force upward. So the electric force is acting upwards. Upwards means along the y-axis. So we have net force acting along y-axis. So for y-axis, we are going to apply Newton's second law, F equal to ma. So the electron are going to experience acceleration along y-axis. So the net force that acting on the electron is the electric force. So Fe equal to ma. The A here will be referred to the component Y, acceleration along component Y. So electric force is QE. So M, acceleration component Y. So rearrange the acceleration component Y will be QE over M. QE over M, then we can put in the value. The elementary charge for one electron is 1.6 to the power of negative 19. You might check it at the list of constant. Then the electric field strength. The electric field strength can be calculated from the equations. Electric field strength for parallel plate is the potential difference applied across the plate divided by the separations. So we have the electric field strength will be 200 minus 200 volt over the separation between the plate is 15 to the power of negative 3, 15 millimeter, okay, divide by the mass of the electron. We can calculate, the mass of the electron we can get the value from the list of constant. So if you refer list of constant, the mass of electron is 9.11 to the power of negative 31. So you might pause the video and do the calculations. So if you calculate correctly, you should get the acceleration will be 4.689 to the power of 15 meter second minus 2. Alright, that one will be the acceleration for the electron along y-axis. Okay, what about x-axis? So class, if you refer to the force that we're sketching, we will find out that the electron only experience electric force acting upward. So the only force acting is upward along y-axis. Along x-axis, secara horizontal, along x-axis, there is no force acting. So summation force along x-axis is equal to 0. There is no force acting. So no force act on electron along x-axis. X-axis means horizontal. secara horizontal tidak ada force bertindak ke atas elektron tu. So if no net force acting on the electron along x-axis, then we understood the acceleration along x-axis, the acceleration component x for sure will be 0 meter per second squared. So this one will be our answer, the acceleration along y-axis and the acceleration along x-axis.